Okay, the last part of this calculus question. Gee, I made a silly mistake in the first video. I got to redo it. So here we go. It tells this story about, we're taking a look at the first derivative, and they tell this story that's a little bit confusing at first, that there's this point E and W that's on a horizontal line, and they're variable points on the line, which makes it more scary on this parabola. Well, I just drew a horizontal line and I called it E and W. Now this line can go up and down, so E and W can get further apart. But they say, think about the tangent lines. There's a tangent line over here, H, a tangent line over here, W. And right away, I'm looking at the symmetry of this situation. And it looks like, hey, these gradients would be almost exactly the same, but one would be positive and one would be negative. That's kind of interesting. But the first question, it also says that these two tangent lines that are formed, H and G, intersect at a point D, which is called A and B. Oh, not everything's variable in what's going on. But they say, okay, tell us what A is. Well, I can see what A is. It's the axis of symmetry right here. The axis of symmetry, the x value of the axis of symmetry of whatever this parabola is. Now, you could use minus b over 2a minus 2 over 2 times minus 3, and I think you'd get 1/3. Or you can just see it's in between 1 and minus 1/3. So it's 2/3 this way, 2/3 from 1. That leaves you at x equals 1/3. Ooh, it says 2/3 there. That was my mistake from before. So I'd like to change that one right there to, I'd like to change this one here right to that number there. We'd like to change it to 1/3 because of the symmetry of the situation. That's what's going on. That just equals 1/3 by symmetry. Okay, so there's A. And now they ask, what about B? For which values of B will H and G no longer be tangents? Well, I could move it down here, and it would still, these two tangents would cross each other. And matter of fact, I could move it way, way, way down, and there'd still be some kind of tangent that would be way, way up here. If I went x is 100 on this side, and then I went that far over on the other side, I could go as far up as I want. But if I came down here and I stopped right there, these two tangent lines would be, H and G would become the same. And that would be the last point. They'd be tangents. If I drop below this point here, they're no longer tangent lines. Well, that's going to be my answer. Let's take 1/3, put it in the function. I get 4/3. So when y is 4/3 right here, when the y value is 4/3, anywhere below, they'll stop being tangents, the H and G going to this point A and B. So your answer is, when does it stop being tangents? No longer tangents when b is less than 4/3. B is any real number less than 4/3. So that was kind of tricky, but I think that's the right story, and I fixed it up. And I've got the right axis of symmetry that's going on right here. That's the A value. And if B dropped below here, then it would stop being tangent lines. And so I think we got it all right.